Welcome, friends. Today we are here going to learn about a problem solving on dynamic programming. The problem is known as all pair shortest path, or commonly Floyd Warshall algorithm. This is a type of algorithm where we have to find the shortest path between every pair. Thus, every pair a source and the other is the endpoint. So, if we consider a set of vertices V, which contains the vertex numbers, okay, and I and J are two vertices that belongs to the set V. Let us consider D of ij. D of ij denotes what is the shortest path from I to j, including only the vertex 1 to k, but the kth element is never in use. This means that I am writing it what I have told. It denotes that what is the shortest path from I to j, including only the vertices 1 to k, means I to k, and k to j, where the kth element is never in use. What does this actually mean? Let us first write as we know in any of the dynamic programming, while solving dynamic programming, a program is can be solved by dynamic programming, can be noticed in two ways if they have the following two properties. One is optimal substructure, another is the recursive algorithm. What does optimal substructure means? Optimal substructure means it should the program or the problem should be divided into many small subproblems. And what does recursive algorithm means? There should be a recursion which can be able to solve the problem. So here we first discuss about the recursive algorithm. What is the recursion which is needed to solve this problem? As I told, d of ij k, what does this represent? I have explained earlier, is equal to, let us say, p. What is p? P is the shortest path. Okay, p is the shortest path. Now, what are the conditions that can appear? There can be two conditions. First one, here I have created the kth element, right, or the kth vertex, right? So one can consider the kth vertex and one may not consider the kth vertex. Means first is the, let us say, first kth vertex is not considered, kth element is not considered. Okay, and another one is the, if kth element is considered, right, means I to k and k to j, here it is considered, right? Now, as we know, in any recursive algorithm, we need to get the base condition or the exit condition, because if we don't get the exit condition, the recursion will go through a infinite times and it will give us the wrong result. So what is the base condition in this case? When k is equal to 0, it gives w of ij. What does this means? What does w of ij means? W of ij means the basic or the basic weight which is given in the question, right? And k0 means, what does k0 means? K0 means that there is no inclusion, there is no vertex which is included. Okay, so this is the our recursion algorithm. Please note it, as while I discuss the problem or example, you can analyze it by your own. Okay, I think you have understood till here, right? Now let us take an example. Okay, I am taking a graph here. Here I am taking an undirected graph, but the problem can be also given by a directed graph. Okay, so this weight is 7, 2, and what are these? These are the weights. Okay, these are the weights of each vertex, and anyone can give a negative weight, but one should be aware that there should not be a negative weight cycle, as if a negative weight cycle after every iteration or after every recursion, it will give a different result and it may be minimum, so we cannot get the optimized result, right? So there can be a negative weight, but there should not be a negative weight cycle. Okay, now what does w of ij, what that I have told w of ij, here I am writing as d0. What does 0 means here? That no vertex is included. Okay, it is simply the weight matrix of this graph. What is the size of this array? This is a, as there are n vertices, so the size of this array is n square. Okay, so 1 to 1, as there is, we can see as there is no self loop, so it will be 0 weight. 1 to 2, what is the age? What is the weight? 11, right? 1 to 3, it's 1. 1 to 4, it's 6, right? Similarly, it is 11, it is 0, 7, 3, 1, 7, 0, 2, and 6, 3, 2, 0, right? So now let us take a let us solve, and so this is the weight matrix. Either in the example or either in the exam, this or this may be given, right? So you can extend, or you can do any of you can change this to this and this to this, right? So now it comes to the problem solving. D of 1, what does this means? The vertex 1 is taken into consideration. Okay, now how this will change it, let us see. These are our vertices. Now 1 to 1, 1 to 1, there is no cycle, right? You can derive this from this also and this also. I will use the graph because it is a bit easier for me. You can use this also. Okay, so 1 to 1, as there is no self loop, so it will be 0, right? 1 to 2, it's 11. 1 to 3, it's 1, and 1 to 4, it's 6, right? 6. Now 1 to 2, 2 to 1, right? It's 11. 2 to 2, there is no self loop, so it will be 0. Now 2 to 3. Now what does this d1 means here? You will understand. What is the vertex? I have to go from 2 to 3. What are the ways I can grow? So let us take it. Let us take the recursion algorithm once. Excuse me. So the recursion algorithm is, first I can exclude the kth value, kth element. I means from 2 to 3, I can go to 2 to 3 in two ways, like directly and by passing through 1. D1 means that I have taken this element and passed through 1. Okay. Now 2 to 3 directly. 2 to 3 directly, what is the weight I am getting? 7, right? And if I pass through 1, what does it occur? 2 to 1, first I have to go to 2 to 1, and then from 1 to 3, right? 2 to 1, what is the weight? 11. And 1 to 3, 1 2 3, what is the weight? 1, right? So I am writing here 1. So what is the total weight? 12. Which one is the minimum weight among the two? It's 7, right? So answer is 7. So we are taking 7, right? Similarly, 2 to 4. Let us check. Now you can, after practicing one or two problems, you can do it verbally, right? 2 to 4. What is the direct? What it comes direct? 3, right? What is the weight? 3. And if we take 1, okay, 2 to 1, it is 11, and 1 to 4 is 6, right? Then the total weight is 17. Which one is greater? Which one is less? Sorry, it's 3, right? So here it comes 3. So similarly, I am writing it. You can practice it yourself. What are the other vertices? This is the resultant matrix. If we take one of the first vertex, right? By chance, this, if we take the D1 vertex and if we are not taking any vertices, so the result is same. But it may not be the case for every problem. Okay. Now taking D2. What does this means now? It means we are taking in consideration two vertices, that is the first vertex and the second vertex. Okay, that is 1 and 2. Means as we are seeing that here we while going from suppose 2 to 3, while going from 3 to 4. Okay, let us take the example 3 to 4. Here first what we were doing, we were going from 3 to 1 and then 1 to 4. Here we can also take the example of 3 to 2 and then 2 to 4. Okay, and let us understand that by the matrix, by taking the matrix. See 1 to 1, as there is, as we this is the 1 to 1, as there is no self loop, so it will be 0. Now 1 to 2, 1 to 2. Here vertices we are taking 1 to 2, so we cannot include other vertices, so it will be 11, right? Now 1 to 3, it is 1, right? So here it will be 1. 1 to 4 is 6, here it will be 6, right? Now 2 to 1, 2 to 1 it's 11, it's here also 11, then here it will be also 11. 2 to 2, no self loop, 0, no problem. 2 to 3, now 2 to 3, I have included 2. So what was the previous result? Here I have included 1. Okay, so in D1 I have included 1. I will take this matrix with reference. Now I will forget this matrix, right? I will take this matrix with reference. D2 1, what is the minimum here? 7, right? So I will take 2 to 3, it's 7 here also, so the minimum is 7, right? So 2 to 4, 2 to 4, what is minimum? Here on the previous it was 3. 2 to 4, if we take 1, then also it was 3, so here we have included 2, so it will be 3, right? Now 3 to 1, 3 to 1, 3 to 1, 1 is included. If we take 2, what is the result? 3 to 1, it's directly 1, right? The weight is 1. If we take 2, then it is 7 and 11. That is 18, right? So which one is minimum? 1 or 18? 1, right? So it will be 1. Now 3 to 2, here 2 is included, so it will be the same 7. 3 to 3, no self loop, 0. 3 to 4, 3 to 4. So what are the results? 3 to 4, I can get 2, right? Directly I can get 2. If I include 1, then what is the minimum I am getting previously? It was also 2. So now I am taking 2 into consideration. So first I am going 3 to 2, it's 7, and 2 to 4, it's 3. So the total weight is 10. So which one is minimum, 2 or 10? It's 2, right? So here also the minimum will be 2. Similarly, I am writing it here. It will be 6, it will be 3, it will be 2, it will be 0, right? So in D1, D2, there is also no change for this problem. Now I am taking D3 into consideration. While taking D3 into consideration, I will not take this matrix again. I will take this matrix. Okay, now I will take the reference of this matrix, right? So D3, what are the vertices? I have included first one, second one, and third one. Here the kth vertex is 3. Okay. Now 1, 2, 3, and 4. 1, 2, 3, and 4. Okay. As 1 to 1, there is no self loop, 0. Now 1 to 2. Let us write here 1 to 2. What was the previous minimum if when I included 1 and 2 both? It was 11. Now if I include 3, what is the minimum, right? Let us see. 1 to 2, it was minimum was 11. Now while passing to 3 means 1 to 3 and then 3 to 2. Okay. Now let us see. 1 to 3, it was 1, right? So here the weight will be 1 plus 3 to 2. 3 to 2, it was 7, right? So it will be 7. So the total weight comes as 8. Which one is the minimum among the two? 8, right? So 8 will be here. See, there is a change now from the previous matrix to this matrix, right? Now 1 to 3. 1 to 3, as we have considered 3 also here. So what was the minimum right now? 1, right? It will be 1 here also. And now 1 to 4. Let us see if there is any change here. While I have included 2 matrix, what was the minimum? It was 6, right? Now if I take 3 matrix, if I take the third vertex, it's 1 to 3 and then 3 to 4, right? So 1 to 3. 1 to 3, what is the weight? It's 1, right? And 3 to 4, what is the weight? It's 2. Now 1 to 3, it's 1 and 3 to 4, it's 2. What is the net weight? It's 3. Which one is the minimum among the two? 6 and 3. 3, right? So here there is also a change. I think you can understand it now. So I am writing the other vertices. If there is any problem, you can always ask me on the comment section. If you don't understand it, I will take another example and explain you in the next video. Okay. Now comes D4. Here I will not take this as the reference. Here I will take this as the reference, D3. Okay. In D4, what is the kth element now? It's the 4 or the fourth vertex. Okay. Now its 1 to 1 is 0. Now 1 to 2. Up till when we have included the third vertex, the minimum was 8, right? For 1 to 2, when we have included the third vertex, the minimum was 8. Now if I include 4, means 1 to 4, and 4 to 2. Now let us check if there is any change. 1 to 4, what is the weight? It's 6. And 4 to 2, what is the weight? It's 3. So it is 6 here and 3 here. 6 plus 3 means 9, right? So what is the minimum among the two? 8. So there will be no change here. Okay. Similarly, it will be 1, 3. The same problem is here. So I am writing the resultant Now, if you have any doubt, please tell me. I will discuss it I will take another example and discuss it. If I discuss this whole, then it will be a lengthy video, right? So this is the net resultant. This is how we are getting the result. Okay, so let us see the time complexity if we use this. So what is the what do we compute here? What are we computing here? This each cell. There are how many cells in one matrix? N and n means or n square cells, right? Order of n square cells means for every matrix there is order of n square subproblems, right? And how many such matrices are there? Let us see. There are order of n square subproblems, and how many such matrices are there? D1, D2, D3 and D4 means there is our shortest, there we are taking a short for every vertex, right? So there are order of n order of say n such matrices. So what is the total time taken? What is the total time taken? So the total time taken here is order of n into order of n square. This is the number of matrices, number of times we are calculating the subproblems. So the total time is order of n cube. This is the time complexity for solving all pair shortest path or Floyd Warshall algorithm. Okay, and the resultant or all the shortest path is represented in this matrix. In this matrix, we are getting every pair shortest path, all pair shortest path. So that's all for now. In the next video, I will describe the algo of it, and if you have any doubts, please tell on the comment section. Like the video and please subscribe. Thank you.